Hi grade 8 students, how are you today? This is Ma'am Nunez, your teacher in Mathematics 8, and we are now on the third week of the fourth grading period. This week's topic is on the properties of parallel lines cut by a transversal. Given this topic, our objective is to prove properties of parallel lines cut by a transversal. In order for us to easily understand our topic and to achieve our objective, we have here two simplified tasks for this week. First is to illustrate different angle pairs of a parallel line cut by a transversal, and the second one is to identify different angle pairs of parallel lines cut by a transversal. So now, let's start the discussion on the properties, theorems, and postulates of parallel lines cut by a transversal. We have two, A. Parallel postulate, and B. The angles formed by parallel lines cut by a transversal. Now, let's discuss further on the parallel postulate. So if there is a line and a point not on the line, then there is exactly one line through the point that is parallel to the given line. So kindly look at the illustration below. If we can see any of these symbols, then we can surely say that these lines are parallel. Take note that S/M is read as line S is parallel to line M. In geometry, the term parallel is denoted by double slash, which means is parallel to. Also, an arrow is used in diagrams to indicate that lines are parallel. Moreover, the term parallel is used for lines, segments, rays, and planes. A transversal is a line that intersects two or more coplanar lines at two or more distinct points. Now, let's move on to the angles formed by parallel lines cut by a transversal, which includes alternate interior angles, alternate exterior angles, corresponding angles, vertical angles, interior angle on the same side theorem, and exterior angle same side theorem. Alternate interior angles. These are two non-adjacent interior angles on opposite sides of the transversal, which states that if two parallel lines are cut by a transversal, then any pair of alternate interior angles are congruent. Consider looking at the illustration. So we have here the transversal, angles 1, 2, 3, and 4. So in the figure above, the pairs of alternate interior angles are angle 1 and angle 3, angle 2 and angle 4. By the postulate, angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. Since they are congruent, their measures are equal. So the measure of angle 1 is equal to the measure of angle 3, and the measure of angle 2 is equal to the measure of angle 4. Alternate exterior angles. These are two non-adjacent exterior angles on opposite sides of a transversal, which states that if two parallel lines are cut by a transversal, then any pair of alternate exterior angles are congruent. Let's examine this illustration. So we have the transversal, angles 5, 6, 7, and 8. So in the same figure, the pairs of alternate exterior angles are angle 5 and angle 7, angle 6 and angle 8. By the theorem, angle 5 is congruent to angle 7, and angle 6 is congruent to angle 8. Since they are congruent, their measures are equal. So therefore, the measure of angle 5 is equal to the measure of angle 7, and the measure of angle 6 is equal to the measure of angle 8. Now, let's move on to the corresponding angles. So corresponding angles are two non-adjacent angles, one interior and one exterior on the same side of the transversal, which states that if two parallel lines are cut by a transversal, then the corresponding angles are congruent. Let's examine this illustration. Using the same figure, the four pairs of corresponding angles are angle 1 and angle 8, angle 2 and angle 7, angle 5 and angle 4, angle 6 and angle 3. By the theorem, angle 1 is congruent to angle 8, angle 2 is congruent to angle 7, angle 5 is congruent to angle 4, and angle 6 is congruent to angle 3. Since they are congruent, their measures are equal. Therefore, the measure of angle 1 is equal to the measure of angle 8, the measure of angle 2 is equal to the measure of angle 7, measure of angle 5 is equal to the measure of angle 4, and the measure of angle 6 is equal to the measure of angle 3. Vertical angles. Two angles are vertical angles if and only if they are non-adjacent angles formed by two intersecting lines. So, vertical angles are congruent. Let us identify the vertical angles using the same figure. So the four pairs of vertical angles are angle 1 and angle 6, angle 2 and angle 5, angle 3 and angle 8, angle 4 and angle 7. So by the theorem, angle 1 is congruent to angle 6, angle 2 is congruent to angle 5, angle 3 is congruent to angle 8, and angle 4 is congruent to angle 7. Since they are congruent, their measures are equal. Therefore, the measure of angle 1 is equal to the measure of angle 6, the measure of angle 2 is equal to the measure of angle 5, the measure of angle 3 is equal to the measure of angle 8, and the measure of angle 4 is equal to the measure of angle 7. Interior angle same side theorem. So this theorem states that if two parallel lines are cut by a transversal, then the interior angles on the same side of the transversal are supplementary. When we say supplementary, it means that the sum measure of the angles is equal to 180 degrees. Let's again consider this illustration. So in the same figure, the pairs of interior angles on the same side of the transversal are angle 1 and angle 4, angle 2 and angle 3. By the theorem, these pairs of angles are supplementary. Hence, the measure of angle 1 plus the measure of angle 4 is equal to 180 degrees, and the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. And the last is exterior angle same side theorem. This theorem states that if two parallel lines are cut by a transversal, then the exterior angles on the same side of the transversal are supplementary. Looking at this illustration, we have angles 5, 6, 7, and 8. So using the same figure, the pairs of exterior angles on the same side of the transversal are angle 5 and angle 8, angle 6 and angle 7. By the theorem, these pairs of angles are supplementary. Hence, the measure of angle 5 plus the measure of angle 8 is equal to 180 degrees, and the measure of angle 6 plus the measure of angle 7 is equal to 180 degrees. We are done with our discussion. So now I think you're ready for our activity. So we have here activity 1. What do I illustrate? So given the figure below, identify what property is being illustrated in each number. Write your answer in your answer sheet. Number 1. Angle 5 and angle 2. So what property is being illustrated by angle 5 and angle 2? Angle 5 and angle 2 are vertical angles, correct. For number 2, angle 1 and angle 4. So they are an interior angle on the same side of the transversal. How about number 3, angle 6 and angle 7? So they are exterior angles on the same side of the transversal. So continue answering numbers 4 and 5. Let's proceed to activity number 2. Give me more. Identify the different angle pairs from the given parallel lines cut by a transversal. Give all that is asked in each item. Write your answer in your answer sheet. So let us use this figure. Line R is parallel to line S with P as our transversal. So angles were also labeled for your reference. So using the figure, shown in the previous page, you are going to identify, or you are going to give or list the 4 pairs of vertical angles. Use only the angle number. Then number 2, alternate interior angles, and so on. To summarize what you have learned, you're going to read each statement carefully and write the word true if the statement is correct and false if it is wrong. Write your answer in your answer sheet. For number 1, is it true or false? Alternate interior angles are congruent. How about number 2? Corresponding angles are congruent. So continue reading the statement and then identify whether it is true or false. So in order to assess whether you have learned something from the discussion, let us answer this 5-item assessment. You're going to read each statement carefully, then choose the letter of the correct answer from the given choices. So refer to the illustration on the right. Given that line U is parallel to line V with W as our transversal. Number 1. What do you call the line W? A. Bisector, B. Base, C. Side, D. Transversal. Number 2. Angle 1 and angle 8 are called blank. A. Vertical angles, B. Corresponding angles, C. Alternate exterior angles, and D. Alternate interior angles. Number 3. Angle 6 and angle 2 are called blank. A. Alternate exterior angles, B. Alternate interior angles, C. Corresponding angles, and D. Vertical angles. Number 4. Which pair of angles are supplementary? A. Angle 1 and angle 4, B. Angle 3 and angle 5, C. Angle 4 and angle 8, D. Angle 6 and angle 7. Number 5. Given 2 parallel lines cut by a transversal, then a pair of alternate interior angles are blank. A. Complementary, B. Congruent, C. Parallel, D. Perpendicular. Congratulations, students! You are doing a great job. Once again, this is Ma'am Nunez, your teacher in mathematics, saying goodbye and God bless us all.